The second quantum revolution is really about building on the basic research which occurred during the first quantum revolution, where we began to understand and control very fundamental small quantum objects like atoms and molecules. This second quantum revolution is moving from fundamental understanding to more complex systems, including ones that have applications in society, for example, biosensing or making a new quantum computer. The Harvard Quantum Initiative is something that we've been thinking about in the back of our minds actually for about 15 years. And the reason that this is the time is because we have a critical mass of ideas and people here at Harvard.
This is an exciting moment because it's a moment of convergence. It is a tipping point.
The need for a common language to start with, and then to really kind of put all the ideas together and evaluate each other's progress is very, very important.
The people that we have here are world leaders in both experimental and theoretical quantum science. And what we have a specialty in here, and really one of the leading places in the globe for this, is using atoms suspended in space and arranged at our will in space to create quantum computers.
What we can now do is to use these machines as really as a tool for scientific discovery, create, new states of matter. We go to parts of the universe, if you want, where no one has ever been.
What we're seeing within the Harvard Quantum Initiative is that a lot of these areas are really propelled by collaborative research. So for example, in the case of the atoms, there's multiple professors that are working in these areas. They meet, they discuss new ideas, they come up with new ways of using quantum bits, these atoms and molecules, to create a quantum computer. That's an absolute strength of the HQI and our research program.
We have this new QSE, Quantum Science and Engineering PhD program. This grew out of an attempt to not just go more quantum, which is obvious, but also go more interdisciplinary.
It's not just a graduate program that involves changing the fundamentals, the courses people take, the rotations they take in research labs. I think we've all understood in the past few years, and particularly with the shutdown and the re-examination of what an education should be and what our obligations as educators are, it was time to incorporate new elements into a graduate program. Elements of communication, elements that focus more on what are the opportunities for students to allow them to interface with the outside world to a greater extent.
Without wanting to brag, I think we have some of the best people in this program as not just advisors, PIs, but also the infrastructure in terms of students and postdocs who are here already is just fantastic and is brimming with new ideas. And I think that makes this program definitely special.
It's a really interesting opportunity to be part of a community, to help develop a community, especially in its beginning stages, that is beyond just an offshoot of physics, applied physics. The hope is, I think, for this quantum science and engineering program, that people will be coming from all manners of disciplines, even if they aren't super familiar from quantum mechanics, and especially if they don't think about quantum in the same way that a physicist thinks about it. Maybe they think about it from an engineering point of view. Maybe they think about it from a math point of view. But it really is creating this interesting atmosphere, I think.
We believe that the partnership between academia and industry is absolutely critical to advancing this field. We have to kind of merge, bridge and bring together the absolute top, fundamental science, which is best done at universities, and, most technological advances, which, can be done in industry.
So when we think about the Harvard Quantum Initiative, we really have this amazing opportunity to leverage the variety of things that are going on, not only within Harvard, but also at MIT. connect with the educational programs at UMass Boston, connect with the companies, the startup companies that are already turning some of these quantum technologies into products. And this is something that gives what we might call an unfair advantage to our center in competing for the best students and competing for the best researchers.